Number 4 is a system of equations, again, with 3 equations though, and 3 variables. So the best way to do this again is using the elimination method. And one other thing that we could do here, since they gave us a couple of answers, is if we're getting messed up, at least try plugging in those numbers. And I'll show you that at the end. But let's just go through the process first. So looking at the x's, the y's, and the z's, which one looks like it's the easiest to eliminate first? They all look pretty easy. But I'm just going to choose the y's since those, the z's, since those have the smallest coefficients. So for example, I can choose these two equations. I want opposites, that's a -4. I can multiply this by -2 to make it into a +4. So just copying that off to the side. Let's see, the top one I'll just keep exactly the same. And the bottom one, I have to distribute that -2 to every single term in there. So I get -2x, then times 4 is -8y, then times -2 is +4z, and then times -2 here is going to be +30. And combining those two equations is going to give me, let's see, -5x. Here is -3y. The z's are gone. That's what I intended, is I wanted those as opposites so one of my variables cancel out. And here I get 18, positive. So now I have an equation that's missing a z. However, I need two equations with both the x and y's and the z missing. So I'm going to choose this bottom one and a different one. So I'm going to choose the middle one. It doesn't really matter, but I have to make sure I choose the bottom one since I left that one out last time. And again, we have to eliminate the same variable. That's why I highlighted this, to remind us that, yes, we're eliminating the z's. So to get an opposite, I see a -2 here. I need a +2, so I can multiply that by 2. And I'll just write it underneath here. So the first one I'll copy. That's x plus 4y minus 2z is equal to -15. And the second one, I'll distribute that 2 across both sides of the equations. So that's 10x. 2 times y is 2y, so that's plus 2y. 2 times z, and then 2 times -12 is -24. And combining those two equations again, I get 11x. Here I have plus 6y. The z's are gone again, like I intended, so now both the z's are missing from both equations. And here I get -39. Alright, so we have two equations, two variables, and it just becomes a 2x2 system. So now I got to put those together and eliminate a variable again. And here I can see the y's are probably going to be the easier ones to eliminate, right? Because I can quickly multiply this one by 2, and it'll cancel out the y's with a -6 and a +6. So let's multiply this top equation by 2. So multiplying it by 2, I have to distribute across both sides. So 2 times -5 is -10. 2 times -3 is -6. And then 2 times 18 is 36. This one I didn't multiply, so I'll just copy that straight underneath. And now, when I add these together, let's see, this becomes 1x, or just x. The y's are gone this time, that's what I intended. And I get the z, the number, the constant, is just equal to -3. So I see my x is equal to -3. And looking at the solutions, I can see that it's either B or C, because since I have an actual solution now, it can no longer be this, it can no longer be that. The only time it's no solution is if you get something that's where all the variables cancel out, and we get something like this, where it's not true. Infinitely many is where you get something that is true, usually 0 equals 0. So now we just have to figure out what's y and what's z, and we can find that just by back substituting. Meaning just by going backwards and plugging in x into one of our equations. So when we bracketed, that kind of tells us where we can back up to. You get the choice of where you want to go. So plugging in this x into one of these equations, I'll just choose this one since it has smaller numbers. I'm going to plug the x into this equation here and get -5 times x, which I now know is -3, minus 3 times y. We don't know that yet. That's what we're trying to figure out. And now let's get y by itself. So here I get 15 minus 3y is equal to 18. Moving the 15 to the other side, so I get 18 minus 15 is equal to 3. And then dividing by 3, negative 3, I get y is equal to negative 1. So far we have x, we have y is negative 1. So that's already enough for me to answer the question, which is B. But let's just go through the last step of substituting in x and y to find z, just in case those were the same. So I can choose any one of the original bracketed equations now, and I'm trying to find z. So I'll just choose the last one just because z is already a z by itself here. So I'll plug in the x here. 5 times x, which is negative 3, plus y, which is negative 1, plus z is equal to negative 12. And now let's get z by itself. So here I have negative 15 plus negative 1. Combining these like terms gives me negative 16. And lastly, moving the 16 to the other side gives us a plus 16 minus 12 is 4. And now we have all three variables. I have negative 3 for x, negative 1 for y, and then 4 for z, which matches up again with B.